This video will focus on scatter plots and how we make interpretations with them. So before we talk about scatter plots, let's talk first about data. So if we think about what data is, that could be almost anything that we can keep track of. So we can measure things, we can measure lengths, we can measure percentages, we can write down colors. There are, by and large, two types of data. There are categorical data, which basically you're sorting things into groups. So this would be like if I have a bag of M&Ms, I'm going to sort them all by color. Categorical data is useful. It's something that we've talked a lot about in the past, but we're going to build to the second type, which is what we call quantitative data. Okay, now this one's a little bit different. This one is more about measurement. It's more about assigning values to things. So quantitative data and how it would vary from categorical data, as opposed to sorting things into groups and then counting how many, I'm giving each potential thing a different data value. So like, for instance, we're looking at test scores. That is quantitative data. Everybody gets their own potential data point. We could collect shoe sizes, heights, weights, anything that we can assign a particular value to. And if we look at quantitative data, and that's what we'll largely be looking at today, that's where scatter plots are mostly useful. So in particular, if we're looking at a scatter plot, sometimes we call them XY plots. They do inherit a lot of the things that are similar to coordinate grids. So as our example, we're comparing two sets of quantitative data. Okay? Now, it has to be quantitative data because we have to be assigning values to something. So the example I have here in this plot is we compare shoe size to height. So for example, if I wear a shoe size 11, let's let that be the x-axis, and my y-axis, let's say I'm 6 feet tall, and we'll make it to where we're measuring height in feet. So if I'm looking at this, I would go all the way over to 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I would go up to 6. And I would make a dot right there. Now, we could do this for any number of data points. Say, for example, we do another one. Let's say we have a shoe size of 7 and we're only 5 feet tall, just as an example. So I go over to 7. There's 7 right there. And I go up to 5. And there's a data point. Now, we could also do another one. We could talk about a shoe size of 11 and only 5.5 feet tall. So that would mean we're just short of that 6-foot mark on the dot anyway. So you can do this for any number of data points, and it's important that both of these axes are things that you can assign a value to. Now what I mean by that is, okay, say we look at using that M&M color example. And on the y-axis we just measure the frequency. It wouldn't make sense for me to do a scatter plot with this, because how do you assign a value to color? What would your x-coordinate be for blue? Do you see the issue there would be more of, what do I do with this axis? That is where the problem lies. So this one I can't necessarily do a scatter plot for. I can only do it for something like this, where I can compare two things that I can actually measure or assign a value to. Now, the whole reason we talk about scatter plots is that statisticians and scientists use them all the time to make what the textbook is calling associations. And we'll discuss further terms on what it means, but an association basically means that there's a trend, there's a pattern, there's something going on there. So this helps us with our interpretation piece. So let's say, for example, this red circled graph that I have here. Let's say that's an example scatter plot. And let's say, for the sake of that we are looking at shoe size versus height. Okay? Overall, this is going up as I go to the right. We would call that a positive association. And what that means is that as my shoe size increases, generally speaking, your height increases. And this isn't so much worrying about if it makes sense or not. It's just based on our data, what are we seeing? So if we change gears and we look at this one that I've circled in blue, and let's say it's the same thing, shoe size versus height. If it's going down as I go to the right, that's what we call a negative association. Okay, and what that would mean is that as my shoe size increases, my height actually decreases. So the whole idea is that maybe I'm using these, and maybe the shoe size and the height isn't the best example, because I could measure both of those quite easily. However, let's say I was using shoe size to predict something else that's not as easily predictable, like, I don't know, test score. We could find some weird trend that says, okay, based on how big your shoes are, we can determine how well you will do on a test. So if it's going up as it's going right, it's a positive. If it's going down as it's going to the right, it's a negative association. And then we have one last example here. And let's say, for the sake, we're still looking at shoe size and height. And let's say our scatter plot turned out like this. I have no idea what kind of relationship there is between shoe size and height. It's all over the place. So this one we would say there is no association. Meaning that, okay, let's say we have a shoe size of 11 here. I have no idea what the height could be. It could be anything. Same if I pick shoe size of 4. It could be any of these. There's not really a good way to predict. Not when we're comparing it to either of these two, where if we pick a shoe size, we can get a pretty good idea of where we land.